Hey guys, this is number 27, continuation of Wednesday, day 3 of chapter 24. Number 27 is found on page 571, so go ahead and take a look at that. Okay, it's the one on the bottom of the page. What you will notice here is that, go ahead and pause the video and read through. Okay, so we're back. So, it's talking about the Olympics, which is kind of unfortunate or appropriate, I guess, timely. You guys know that the 2020 Olympics that were supposed to happen this summer in July were postponed. They're thinking about, I don't know, it could be the spring next year, but most likely will not be in 2020. So this affects, I wonder how this affects all the Olympians. You know, all those people have really prepared their whole lives for this event, and 1 more year is just more time to prepare. And those events that already had qualifiers, I wonder if they have to qualify again. I don't know. Anyways, so we're talking about running here. We're talking about a 400 meter sprint. Okay, so that's approximately, that is 1 lap around the football field on the track. So we have 2 groups of women running. We have a group running in heat 2 and heat 5. So heats, if you are familiar with running or swimming, a heat is just groups. Like think of, on the running track, there are usually a maximum of 8 lanes. So you can't have everyone running at the same time if there's 200 people, right? You have to break them up in different heats. And they, according to our given information, they randomly assign that. All right, so let's check this out. So our given data, this time, we don't have any statistics. We don't have the sample mean or the sample standard deviation, but we could calculate it, right? Using 1var stats. If you forgot how to go there, remember it's gonna be stat calc, and it's the first option right there. Okay, but when you do that, it's gonna ask you for a list. So you have to specify which list. Are you using list 1, are you gonna use list 3, or another list that you named. So our mu for mu sub 2 is, I'm going to use 2 and 5 for the 2 different heats. This is the true mean time for heat 2. It's going to be the true mean time for heat 5. So what are our null and alternative hypotheses? Go ahead and pause the video and take a look and see if you can figure that out. So we know that mu sub 2 is equal to mu sub 5, or we could say mu sub 2 minus mu sub 5 is equal to 0. See, mu sub 2, it says is different, okay? So is not equal to mu sub 5, or mu sub 2 minus mu sub 5 is not equal to 0. So either one works. Okay, so let's jump in. So to save time, I wrote out the other parts. I want to talk about the n, okay? But let's just go over our test, our 2 sample mean test. Alpha, we're going to use 0.05, but it's up to you. Tails, let's stick with 2. This is 2 tails because it is not equal to. For independence, we assume each runner is independent in both heats. We assume each runner was randomly selected. We know that's not true. You don't just randomly select people to run in the Olympics. They have to qualify, right? They have to be really the best of the best. However, we also know runners are randomly assigned to heats. That was in our given information. We assume that 7 runners is less than 10% of the population in heat 2. So there could be, we want to know what was our population. We assume that there are more than 70 runners that could have qualified. Right? From around the world, there must be more than 70. We assume that 7 runners is less than 10% of the population in heat 5. We're going to proceed with caution. Now for n here, take a look at page 549 again, or 550 maybe. This time we're given the data. What that means is we have to show, actually I'm going to go to 550. Okay, it's actually 552. Okay. In the nearly normal condition, so 552, Right here, the samples are small, but histograms look unimodal and symmetric. Now, if you're given the data, you have to draw out the histogram, okay? So let's check this out. So what I'm gonna do is I'm gonna go to my list, and I'm going to input the runners from heat 2 into list 1. So let me write that down on a separate sheet of paper. So in list 1, I'm going to input the heat 2 times, and then L2, I'm going to input heat 5 times. All right. So I'm going to go put those in. Go ahead and pause the video and you can put yours in. I'm missing one here, 56.01. All right. And then I'm going to make a histogram. Do you guys remember how to do that? So a histogram is going to graph these separately. So let's just do a histogram for list 1. So I'm going to go to second, stat. And notice I have 2 plots turned on right now. So I'm going to turn off the second one. Okay, you'll get an error message. So I'm going to go back to plot 1. And I'm going to choose a histogram, is this one right here. And I'm going to use list 1. Okay, so I'm going to hit graph. So right now with my setting, that's what my histogram looked like, but I'm gonna go to zoom 9. And as you can see, this is not normal at all. So I'm gonna just take a quick closer look because it looks like most of my times are in one section. And if I look at the data, I can see, sorry if this is insensitive, but there's one slowpoke here. I shouldn't call him a slowpoke because he could probably run faster than, I don't know about all of you, but definitely faster than me. All right, 56 seconds. There's one female, Bo Fanfang from China, who ran a 56.01, which is considerably slower, faster than the rest of us humans, but considerably slower than the rest of the group. Okay, so could she be an outlier? Let's think about that. Now, how can I quickly see if she's an outlier? Now, I know my formula, right? I could check. Should I check using, remember, Q1 minus 1.5 times IQR and Q3 plus 1.5 times IQR? I could do that, or is there a faster way to check if she's an actual outlier? If you said box plot, you're correct. Yay. So go to second stat plot, and the plot that's on right now, look at, for the type, choose the box plot with the 2 dots to the right, because those are the outliers. So I'm going to hit enter, and I'm going to use list 1. I'm going to go graph, zoom 9. Now notice that that point right there is an outlier. So Bo Fanfang from China is an outlier. So now you got choices. You can keep the outlier in there, or you can omit it. Okay? But if you're going to omit it, you have to say that in here. You're going to take out the outlier. And also right here, for the first group, instead of having 7 runners, since you took out Bo Fanfang, you would say you have 6 runners there. Everything else should be the same. So you guys decide right now. I'm going to do it both ways, okay? Okay. So since she's an outlier, we're going to draw for this part right here. Let's just say you decided to remove, okay, so you remove outlier from heat 2. Okay, if you do that, let's see what your normal curve or your histogram looks like. Second stat, go back to my histogram. So I'm gonna go stat, edit, and I'm gonna go down to 56.01. I'm gonna delete that, okay? Delete. Now I'm gonna go back to my graph, my histogram, make sure it's histogram plot 1, and I'm gonna go graph, zoom 9. So it still ain't normal, but you know what? I'm gonna proceed because at least I got rid of my outlier. So I'm gonna draw this. You just need to sketch it, okay? Sketch. Sketch is a key word. Like this, 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 this. You don't have to give any values to your x-axis, okay? So I'm just going to say this is heat 2. And I need to do the same thing for heat 5. So I'm going to go to list 2 this time, okay? So I'm going to graph, zoom 9. Oops, what did I just do? No. Hey, that's what it looks like. Wait a minute, is that an outlier right there? I'm gonna go back to my raw data, and it looks like the runner from Sri Lanka, her time was a little bit slow. So I'm gonna go check the box plot again. Go to plot 2, check the box plot right here. I'm gonna graph, zoom 9. Now it shows that she is not an outlier. However, that one time, if you eliminate that, let's see what happens. If you eliminate that, your tail right here is going to be a lot less, but it's not an outlier. So should we keep her? Should we not keep her? I'm just going to keep her, but it's totally up to you, okay? You've got choices. This is America. You have choices. You choose what you want to do, but you have to list it in your conditions and assumptions, okay? So I'm going to choose to keep her. So I'm going to graph using my histogram. Graph. Zoom 9. So for my view, heat 5, okay, kind of looks like this. So we have to say distributions are not normal. However, we will assume so, which sounds crazy, right? But that's what you need to do. You just need to state in here what is, I don't want to say wrong, but what certain conditions are not met, okay? So now let's go here. So I'm going to go back, let's do our data without Bofanfang, okay? So I'm going to go to stat, test, and we're in the fourth option. So here now you have a choice. You can go and calculate the statistics for each group using your list, right? Using 1var stats. Or you could just go back to your data. All right, so I just went over to data on the left, and I'm going to use L1, L2. Now your frequency list 1 and 2, just keep that as 1, okay? So I'm going to leave it like that, and I'm going to say it's not equal to mu sub 2. Pooled, just keep it as no, and then calculate. So when I do this, I get a t-score of negative 1.141 and a p-value of 0.284. All right. So let's compare that to with the outlier in. So I'm going to go back to my list, edit, and I'm going to re-input her time, Bofanfang's time, 56.01. Okay, and I'm going to go to stat, test. Again, so you can go to stat, right, and you can recalculate. You can go back. Remember the example we did a little bit earlier today? This was number 21A. You can go back and calculate these using 1var stats. Or you could just use a data option. So, oops. So stat, test, data, use L1, L2, and then I'm going to go to calculate. And this time, our t-score is 0.0346, and our p-value is 0.973. So our p-value is really, really high, almost close to 1. So looking at this, you can decide which one you want to use, but you have to be consistent. You don't have to list both, but you pick one depending on what you did in here, in this section. Okay? Did you omit the outlier, or did you keep her in? Did you omit the possible value, the Sri Lankan runner from Heat 5, or did you keep her in? So I guess we could calculate this with taking out the Sri Lankan runner as well. But I think you guys get the point. So finally, let's go ahead and write our summary our conclusion. And it's going to be the same, right? If you guys take a look right here, your p-values are both greater than 0.05. Since the p-value of whatever is greater than alpha of 0.05, we fail to reject the null. The null being that the mean times of the two heats are different, are the same, I'm sorry. We do not have evidence that the true mean times of heat 2 and heat 5 are different or not equal to. Okay? So now, what type of error could we have made here? We failed to reject, so the only type of error we can make is type 2. All right, so play around with this. Number 27 had a lot of like moving parts right there. All right, guys, see you later.